Welcome to the walkthrough for Assignment 3, Part A. The objective of the first part of this assignment is to learn how to use the Java Executor Completion Service framework. Videos describing this framework appear here and here. I recommend you watch these videos to ensure you understand the Java Executor Completion Service. Naturally, we'll also cover these topics in class. In this part of the assignment, you'll use an instance of the Java Executor Completion Service class that's associated with a cached pool of threads to augment the fixed-size thread pool implementation of the Palantiri simulator app from Assignment 2A. Assignment 3A focuses on creating a cache pool of threads that allow beings from Middle-earth to concurrently gaze into a given number of Palantiri. The Palantiri simulator app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java, and as always, demonstrates many Android capabilities. For the purposes of Assignment 3A, however, you only need to be aware of the following three directories. Simulator Manager's Beings Completion Service, which contains the skeletons you need to fill in, as we'll discuss shortly. App Service Test, which is a set of unit tests that exercise many Palantiri simulator features and can be used to help test the functionality you implement for the assignment. And App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. You'll also need to integrate your enhanced solution for the reentrant lock hash map simple semaphore folder from Assignment 2B and use it as the implementation of the Palantiri Manager for Assignment 3A. Please address all my comments from Assignment 2B in your Assignment 3A solution. To compile this code, you need to use the provided Android Studio project. You can run this project as always by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created, which naturally you should by this point. The app's minimum API is 29, so you'll need to select an emulator that uses an API greater than or equal to 29, though I recommend you use API 30. If you don't already have an emulator created, or you don't like the one you had created earlier, you can create it by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the Java and skeleton code by completing the to-do you fill in here tasks to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks, and please don't delete the to-do tags. In particular, you'll need to finish implementing the following to-do tasks for this implementation in the completion service folder. Executor Completion Service Manager.java, where you'll need to complete the to-do tasks in various methods to implement a being manager via a cached thread pool using the Java Executor Service and Executor Completion Service. For being callable.java, you'll need to complete a couple of methods in this class, which should look very familiar by now. You'll also have to update the student KT file to complete the to-do tasks to set the type field to either graduate or undergraduate, depending on which version of the assignment that you'll be implementing. As always, your app will be considered correct if it passes all the unit instrumentation tests and all beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri. In other words, if there are 4 Palantiri in the simulation, then only 4 beings should ever be gazing on the screen at any one time. When the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. If the implementation is not implemented correctly or throws an exception, then the red title bar labels will be displayed when the simulation completes. Grad students, or students who are taking this class for graduate credit, must perform the following additional tasks. Enhance the Executor Completion Service Manager.java file to use the Java method references and/or Lambda expressions as instructed. Undergraduates are welcome to implement these methods or features, but it's not required. Skeleton code for this assignment is available as always from my GitHub account. Now that you've set up your GitLab account, you can simply pull this skeleton code into your repository, read it carefully, and complete the to-do markers. This part of the assignment is intended to deepen your knowledge of writing concurrent Java programs using a cached thread pool in conjunction with the Java Executor Completion Service. This solution enhances the Java Executor Service mechanisms covered in Assignment 2A by eliminating the need for an external queue of futures and ensuring that task results are processed as soon as the tasks complete. Now that we've covered the specification of Assignment 3A, let's go ahead and walk through the skeleton files and examine the various to-do tasks you have to fill in. Everything is located in the Beings Completion Service folder. Go ahead and click into there and take a look quickly at the being callable class. This class is very similar to what you've done before, probably in fact identical. And all you need to do is fill in the call method for this being callable class to replace null with the appropriate return value, and also go ahead and implement the acquire, Palantiri, and gaze method. And this should use the implementation that you have done for previous assignments, making sure that you've addressed my comments. You might want to watch the frequently made mistakes videos to see some of the examples of things people have done incorrectly for this particular method. Let's now go ahead and take a look at the Executor Completion Service Manager class. As you can see here, there's a couple of to-dos to fill in for various fields. You have to create an executor service, which will be used to contain a cache pool of threads. We'll talk about where that gets initialized later. Don't initialize it here. You'll also have to have a completion service that's associated with the executor service. We'll also talk in a moment about where to do that initialization as well. Let's come down here and take a look at the new being factory method. And this is a method that the beings implement to return a new being callable instance. You need to go ahead and fill this in to replace null with the appropriate code to make the appropriate type of new being. This should also be very familiar to you by now. Here's the run simulation method. This is the entry point that's called by the simulation framework to start the being gazing simulation. There's three methods you have to call. You have to pass in the appropriate parameters. You have to first call a method that uses the executor service to create and start a pool of threads that represents the beings in the simulation. And you have to go ahead and call a method that waits for all the futures to complete. And then you have to call the methods, this class's shutdown now method to cleanly shut everything down. So let's go ahead and take a look at these various methods here. These are some factory methods and helper methods. Here's the create executor service method. This will go ahead and create a cache thread pool executor service instance. Down here, you can see we're going to have the create executor completion service method. As you'll note, it takes the executor service as a parameter, and it goes ahead and creates an instance of executor completion service, and then that gets returned. That, of course, will also be associated with the executor service. Go back and watch the videos if you have any questions about how to do that. Here's the method called begin being thread pool, which uses the executor service and that has the cache pool of threads associated with it. And so you go ahead and write the code in here that calls the get beings method to iterate through all the callables and submit each being callable to the executor completion service instance to go ahead and start things running. And here again, you'll be able to be clever in your use of Java 8 code, such as the for each method and so on. Undergrads can do that optionally. Grad students should certainly do that. I will probably encourage everybody to do it that way because it's good practice to get into, to use the Java 8 features like the for each method and the lambda expressions and so on wherever you can. Then we have another method called await completion of futures, and this will use a for loop or a for each method, even better, to iterate through the total number of beings, blocking on the executor completion service's take method until there's a completed future available. Remember, the way that the executor completion service works is once you get back a future from take, that has already been completed. Otherwise, it wouldn't end up in the executor completion service completion queue. So at that point, you can just get the results and then use it to log whether something worked or not. And the graduate students basically implement the same logic, but of course, make sure that you use Java 8 methods like for each and so on and lambda expressions, and also use the exception utils rethrow supplier method to avoid the need for doing any try-catch blocks to handle checked exceptions. So the grad students need to make sure their solution does not contain any try-catch blocks to deal with so-called checked exceptions. They would use the rethrow supplier method, which is a little cleaner way of doing things, quite frankly. So in here, make sure that you put your code in the right place. The undergrad students put their code here. Graduate students put their code in this other section. And then the last method here is just called shutdown now. and you go ahead and tell the executor to shut itself down. So that's basically all there is to it. One of the things you'll notice with this particular implementation that's nice is that the whole management of the list of futures that you had to do in assignment 2A disappears completely, because that's been pushed into the executor completion service. So it's no longer the application's responsibility to manage these futures using the so-called synchronous future processing model. But instead, we'll let the Java Executor Completion Service handle the completion of the various futures using the async future processing model. So it's a different model. It's actually a simpler model. If you go back and compare this code with the other code that you wrote, you'll see that it's quite a bit simpler and there's less to have to worry about. Probably the trickiest thing is just to figure out how many times you have to iterate through the await completion of futures methods loop. You have to sort of think about that a little bit. That's a little tricky. Okay, so that's basically what there is for beings for assignment 3A. There's also obviously the Palantiri manager. And what you'll do here is just copy over your code that you had written before for assignment 2B, making sure that you first address my comments. So you'll have the reentrant lock hash map simple semaphore manager and all the code that goes in there correctly implemented, of course, and should pass all those tests too. And also make sure you fill in the correct implementation of the simple semaphore class. And a lot of people got this class wrong in assignment 2B, so make sure you fix it for assignment 3A. Of course, make sure you also fix it for assignment 2B, otherwise you'll get points off for that. But make sure that you fix it for sure for assignment 3A, and make sure that you're passing all the tests as well. Now that we've examined the specification and walked through the skeletons, it's time to run the unit tests. Let's go ahead and run those tests. As you'll see, there's a large number of tests. There's all the tests from before for assignments 1 and 2, which we've updated with the latest checks. Naturally, there's also the test for assignment 3A. When you run the tests, everything should be green, and that's a good indication that your program is most likely correct. Of course, there could still be other things to fix with respect to commenting and style and so on. But make sure you run your tests, make sure your tests pass. If you have any questions about any of the tests not passing, please feel free to come to office hours and I'll help you out.